We charge a capacitor C and we charge it to 15 volts. Then we discharge it through a resistor R. So here is that capacitor, it's fully charged, switch here, resistor here R, throw the switch, at first there is plus 15 volts here, we throw the switch, current is going to flow until the capacitor is completely discharged. Now this R is part of a voltmeter, I shall call it R of V, and that is 2.25 times 10 to the 6 ohms. And what the voltmeter indicates, this is really a voltmeter, is of course the product of the current through the voltmeter times the resistance of the voltmeter. So that's what the reading will show you. You start throwing the switch, what do you see? 15 volts, of course. Now you wait 5 seconds, and what do you see? You only see 1/3 of 15 volts. You only see 5 volts. At least that's a given. Well, if you look in your book at page 848, you see in detail how we set up the differential equation for this circuit. It's extremely simple. And you will find then that the current through this circuit going in this direction as a function of time equals I0 times e to the minus t divided by RC. Sometimes RC is called the discharge time, which is of course a little bit of a jargon, because it takes infinitely long for the whole thing to be discharged. You have to wait for t infinitely long for the current to become zero. Now the voltmeter reads I times R, but since you have the R on the right side as well as on the left side, that's fine, you can ignore that. What you do know, however, is that after 5 seconds, IT over I0 is 1/3. So 1/3 equals e to the minus t over RC. T is 5 seconds over RC. Well, you know R, 2.25 mega ohms. So out pops C, and I found that C equals 2 microfarad. If you make a curve of the current as a function of time, that would look like this. This is the current, this is the time. You start off with some current I0, and it discharges in exponential fashion, and by the time it is down to I0 over E, which is somewhere here, the time t equals RC. That's why it's often called the RC time of the circuit.